Good morning, good evening, or good afternoon, wherever you are in the world. This is MP Strydom, your host of the Mind Warp podcast. Welcome back to Mind Warp. This is the podcast where we talk about all the new and promising innovations and technologies that shape our world, and of course, specifically in the mining and natural resources industry. Let me quickly take the time to thank MineRP. MineRP is the primary sponsor of the Mine War podcast, and as a global software company specializing in delivering value through digitally connecting mining enterprises, MineRP does a lot to establish patterns for collaboration and teamwork across the industry to help their mining customers. You can check them out on www.minerp.com. Today, we're going to talk about an interesting development in the world of digital solutions. I guess it's not brand new, and that is the development of underground drill and blast planning solutions. Of course, when you think mining, it's hard to not also immediately think about drilling and blasting, especially when we're talking underground. There's a lot of additional information that is required to create the ideal drilling pattern and work with the right explosives and figure out what the right way is to charge that hole to make the exact shape of hole that you want to create. And that there, my friends, is as much as I know about drilling and blasting. But luckily, we've got a real expert to tell us all about that. So today we've got Troy Williams joining us. And Troy Williams is a professional engineer with iRing. He is also the incoming president of iRing. Is that right, Troy?
Yeah, that's correct, MP. So I'm basically in transition. September will be the official date where I take over the reins, but I'm currently, my previous role was vice president of the company. I've been working with iRing since 2003, developing drill and blast software. I've been involved with MineRP since probably around 2004 with the old MineCAD product. Our software at the time was based on a CAD system, and it worked. It was ahead of its time at the time, if I do say so myself. Eventually, we migrated it over to a brand new solution called Aegis, which took everything we had learned from the CAD style system, everything that a drill and blast engineer would typically need underground, and encapsulated into a standalone package. And that's been quite successful for us. It's used all over the world. Every major mining district, most of the major mining districts in Africa, Australia, South America, and Europe. So what I've been focusing on most of my work throughout my career is better ways to do underground drilling and blasting. And from what we've seen, it usually starts with planning. If you don't have a good plan, the rest of the downstream process will not work correctly. And as you're aware, if your fragmentation goals aren't met, everything downstream has to compensate for the shortcomings of the drill and blast cycle. If you get good drilling and blasting, everything else downstream is easy.
Just before you carry on, if you say planning there, you're not talking about the life of mine plan or the medium term. You are talking about planning that immediate drill ring that's got to be blasted, right?
Yes. That immediate stope, a stope by stope basis. That tends to be my focus. I'm not overly concerned about where that stope blast fits into the schedule or things like that. I'm concerned with getting that immediate stope out. So it's a very hyper localized specialty, essentially.
Sure.
So essentially, what we're trying to do is we're trying to redesign, to look at drilling and blasting in a new way, as opposed to just throwing lines on a paper and submitting a plot and hoping for the best. We want to remove a lot of the trial and error and actually move it over to simulation. Will the blast function the way you expect it, given the rock properties that you understand, given the explosive properties, and given the constraints within modern drilling and blasting? Can the holes be drilled accurately? Can they be charged and loaded correctly? Can you actually measure the results and feed that back in to improve your process? Can you design a blast to produce fragmentation to, say, bypass primary crushing underground, for example, and do that consistently? These are questions that we're working towards answering. And there's some mines around the world that are doing a good job at it, but when you really get down to it, a lot of it is based on trial and error and the quality of the engineers involved in the blast. Not every mine has access to that.
You just use the word consistently,
Yeah.
and I guess from talking to you before in our preparation, you talked about turning the blast into a repeatable industrial process. I found that very interesting because from the outside, at least, it seems like blasting is something that is chaotic by nature, but it's not, is it?
No, it's not. It looks that way. It definitely looks chaotic by nature, and a lot of places will call it a black art. But that's only because
Yeah.
it's not well understood. Like the science of the explosives is pretty old and goes back to Nobel. But it's the rock that's the problem. The thing we want to break, a lot of places don't fully understand the properties required to break this. Like there's a lot of science and a lot of knowledge going into characterizing the ore body in terms of grade. They know where the grades are, they know how it behaves. They've got very accurate models. You've got the implicit modeling that's out, which is fantastic.
Mhm.
But nothing goes into characterizing the material in a destructive sense. Like if you're looking at
Yes.
ground control, they've got some very good ideas and very good models on how to keep that ground from moving, but that's really not what we want to do in drill and blast. We want to break it. And it seems that blast engineering is one of the few engineering disciplines that are trying to apply an engineering solution to a material that they don't fully understand. And let's face it, rock is complex. It's very complex, and thousands of PhDs have been working on this problem for a long time. And it's a tough thing to characterize, but that's one of the keys to designing a good blast, understanding the material you're working with. And in lieu of having a good idea of the rock properties, a good comprehensive feedback loop is important. Design a blast, predict what you're going to get, and then measure what you get. Did you get it?
Yeah.
Yes or no? How do we improve this? What do the results mean? If you're getting fragmentation that's too fine, well, there's a number of things that could be a problem. Is it too coarse? There's a number of other things that could be a problem. Let's see
Right.
what we understand about what we did and fix it. Was your drilling correct? Was your charging correct? Those are some of the
Mm.
simpler things. But then when you get down to the rock itself, how was the jointing? What were the elastic properties like? Do we know what the elastic properties were? So those are some of the
Mm.
challenges we've found in designing a good blast underground. So consequently, most tools out there and any of the standard tools that a blind engineer would use, including our package, will help you design a blast quickly and accurately. But our tool differs from these, and it allows you to apply some advanced tools in what we call our analyzer package, where you can take a look at the rock material. And for one, we have what we call our break model that will help you understand the pattern you should be using given the rock and the explosive combination. And the
Yeah.
reason I use combination is because you can't look at it separately. It's a system. If you change the explosive or the rock changes, it's an
Yeah.
entirely different system. So you have to design to that system. And we've had some good success with that. But like any simulation, it falls down on the input data. If the input data is not very good, the predictions aren't going to be very good. Like we've seen, like the model really relies on the elastic properties of the material,
Mm.
like Young's modulus and Poisson's ratio. I'm going to use some bigger words, but ultimately, what it boils down to is that blasting is fundamentally different than rock mechanics, because in blasting you have shock loading, and under shock loading rock behaves differently. It's actually a bit stronger. It's a bit stronger in most cases. So using the
Okay.
numbers of compressive strength and tensile strength within a rock mechanics sense or a ground control sense is may not give you the correct picture, because under a shock loading that rock may be actually significantly stronger than
Mm.
than than under a static loading event. So those are some of the problems that we're encountering. And part of that, like our break model is pretty good at telling you what pattern to use, but it won't tell you the fragmentation that you're going to get. So you're still it's a bit like sailing a ship in the dark with no navigational aids. You have a general
Right.
idea where you need to go, but there's not a lot to help you. So we're rebuilding the concept of a fragmentation model from the ground up. Now,
Okay.
there's some fantastic models on the market, but they're all finite element analysis models. Basically, it means that it takes a really long time to get a result. In mining,
Yes.
we have a very quick cycle time. Even on big stopes, they don't take a relatively long time. Like if you wanted to fully model a stope and see what a blast would look like, that stope would be mucked out and filled by the time that some of these models would complete, and that's kind of useless. So we're
Mhm.
taking more of an engineering modeling approach. We know there's going to be inaccuracies in the model, but if it's out by 5%, maybe 10%, who cares? As long as you get
Yeah, it doesn't
you
have to be exactly perfect, does it?
exactly, exactly. It doesn't have to be, because even in the measuring side of things, you're not going to get down to micrometer accuracy. There's limitations in the system. So we're
Mm.
working on an engineering fragmentation model from the ground up that is going to complement our current technology and allow an engineer to design a blast and see what kind of fragmentation that model would produce. And the idea is they would design the blast with good rock properties, with a good understanding of the explosive, and then what the mill needs, right? As a lot of mining operations just are concerned with getting the muck out of the ground, not so much
Mm.
with what the mill is looking for. So with that in hand, then we're obviously still limited by the drilling and the loading. Now, with drilling, the interesting thing there is there's a lot of really nice autonomous drills coming out.
Mm.
But what really I'm excited about is the measure while drilling technology. How hard or how easy was it for the drill strings to measure? If we can capture that and feed that back into our modeling, we can start to get local strength property. You can infer local strength properties from that material and help with that. At a very naive approach, if we understand where the holes are through gyroscopic surveys, we can feed that back into our model, and then the engineering team can make a decision. They can feed it into our model, take a look at what fragmentation the actual holes will produce if nothing else changes, and then make a decision. Do we need to get in there and redrill? Is the
Mm. But
fragmentation
so
within an acceptable range?
you've talked about a lot of things now. Starting from the, I guess, the input model that you get of the rock to going beyond merely using a CAD system to draw a set of strings to for a drill plan, to actually analyzing that model that you've got and then improving the model
Mhm,
uh, based on, let's call it, live or semi-live feedback, post-blast feedback that you get from the drills as the drilling is happening,
mhm.
to using post-blasting fragmentation analysis to further improve your model. And all of that, uh, when you combine that with everything else, makes up an incredible amount of information that needs to be put together and synthesized and then reanalyzed and remodeled, I guess. What do you do to prevent that from taking so much time that by the time you get up, you come up with an answer, the next round has already started and you're already behind the eight ball?
Well, it should be a staged process essentially, where the design is done to the best of the engineering team's ability, right? So they know
Mm.
the stope, they know the mining method they wanted to use, then they can shoot well, actually, we should be able to do it fast enough that they could potentially change mining methods if they wanted to on a stope by stope basis to adapt to the ground conditions that they believe are there at the time. Then the next stage would be, once the holes are drilled, bring those back as soon as possible into the model and then adjust, see what the plans are going to be. Do you need to adjust anything? Do you need to bring the drill back in to get new holes because the fragmentation will be out of spec for a particular ring? All that should work while the drill is almost still there or not very far away to be able to process that. It's
Mm.
really not much of a
Exactly.
change. It's not much of a change from what they're already doing, because you're right, MP. If it takes too long, it's simply not going to do it. It's not a feasible model. It has to be work within the mining cycle. I like to one of the problems we're going to face is measuring the fragmentation. In my mind, it has to be done by laser scanners to get a good 3D point cloud of that thing. But the problem
Mhm.
with that is, can you get the laser scanner to get the resolution you need in the cycle time? Because you
Mm.
can't just take one scan. You have to take multiple scans to build up a profile. Can you get it in there while that scoop is working and mucking and without interfering with the cycle? If you can't, then it's not a feasible way to do it. And that's our whole philosophy behind this, is try to make something that's non-intrusive, something that is a no-brainer to adopt, not something that you've got to change the whole
Mm.
process. And
Mm.
that's where
Mm.
we're focusing on. One of the other areas we're working on a fragmentation model. We're hoping to have that done by the end of the year, and it's going to have proper grounds in physics and mathematics. It's not going to be something like an approximation or an empirical model like a Kurzram or a Swiebrich model where you have a whole bunch of calibration points and basically you can make it do whatever you want regardless of what you're modeling in reality. One thing though we've found that any modeling will fall down in is the proper input of data. What is the proper density of
Of
the
course.
material you're dealing with? What are the rock properties? What are the PNS wave velocity? So we're working on a brand new geomechanics probe that we call RockScan. And the difference with this probe is that it measures strain deformation of the rock mass directly. So it's inserted into an NQ diamond drill hole within the rock mass, and it measures the subtle changes of the rock mass due to stress, due to blast wave travel, due to seismic wave travel. And from those waves, we can infer very accurate rock properties. And more importantly, we can infer local rock properties to the rock that you're
Okay.
blasting, not a global wide system.
So this is almost it's not only about measuring how deep and at what angle you manage to drill, but it also measures the effect of the drilling post the drilling
Yeah.
and and gives you more information on the actual property of the rock before you charge the hole.
Yes, exactly, exactly. I like to think of it as somewhat of a seismic tomography system where you can essentially scan the rock, and instead of getting geology numbers where would be, grades, it's giving you
Right.
material properties. I like to, one of the things I like to look at as far as blasting and holes are concerned, holes are simply delivery mechanisms for the energy that we want to use to break the rock. And that's how
Okay.
I look at it. I don't particularly look at it as any one particular type of explosive like an emulsion or a water gel or an ANFO. I look at it as the amount of energy being delivered. Can we get it to the right spot and
Hmm.
set that energy off at the right time? And really, it sounds simplified, but it really is that simple. And in practice, it's obviously not that simple most of the time.
Hmm.
So
Hmm.
with our RockScan product, it's gonna measure the data points in the interesting thing is my interest with this particular probe is the information we're going to be able to get on the rock property so I can feed our models and better predict our blast. But it not only can measure the dynamic changes in the rock, but it can measure static changes over time. So as mines go
Okay.
deeper, you're going to experience more and more stress. So with this particular probe, it's a three-dimensional system, so we can measure three-dimensional stress fields and how it changes over time, which could be very useful to mines at depth.
Yeah.
We theorize that you could potentially use it to help predict rock bursts. Potentially, the research, we still have a lot of research to do in that area. There are applications for this product in civil structures like dams and tunnels, anything you want to see
Yeah.
stress changes. We also theorize that it might be possible to use this probe in tailings dams to see, in that case, what we'd be looking for is, are there any changes? The probe would read, and are
Right.
you looking for any changes? It might be able to detect changes in stress level that could indicate problems
Yeah,
earlier
and
than
those would
other
be
methods.
internal changes as opposed to something that you get when you fly over it with a drone or something like
Yeah,
that.
yeah, you might be able to detect it a lot sooner than you would, even if you had LiDAR scan of this and looking for shape changes or things like that. So that would be
Mm.
something I'm interested in testing to see if it works, see if
Just,
there's any
just out of
correlation.
interest on the topic of those kinds of external scans, you get uh, LiDAR, which of course uses light, and radar,
Mhm.
and ViDAR or video-based detection and ranging is something that's growing a lot, and combined with all of those technologies are sorts of edge-based artificial intelligence kinds of engines that are able to recognize shapes and give some proper responses or suggest some proper responses even while it is doing the work. Is this something that you find is moving in a certain direction? Do you find mining is adopting LiDAR more before adopting radar, or do you see interesting movement there?
Um, on the underground side, it's probably more LiDAR. I haven't seen too much radar being used. Like the autonomous drones that I see moving underground are all LiDAR equipped. I haven't heard
Right.
too much radar. I've heard some research projects. Is one of the big key understanding, the big problems with working with underground blasting is it's not very visual. You can't see what's going on. One of my colleagues, Chris Preston, he's got about 50 years in the industry, and he's done a
Uh-huh.
lot of work on surface, and they would work with high-speed cameras and videotape face movements, and he'd have various apparatuses on the face to understand which parts of the face move at different rates and understand the
Okay.
burden movement velocities. Those type of measurements are very, very difficult to do underground. But some of the suggestions and some of the work that I've seen done, it involves radar to try and
Hmm.
measure that sort of thing. But obviously, they'd most likely be destroyed if they were in the line. But those are some of the challenges we end up working with. But yeah, as far as that technology adoption, I honestly I don't pay that much attention to it. I'm just assuming that on the survey side, they provide us with good quality point clouds representing the fragmented
Yeah.
muck that we want. That's really my concern. Is if I focused on too many things, I'd never get anything done.
From the amount of information that you rattled off, it sounds like you could run the risk of focusing on too many things. But it also sounds like you're probably able to handle it.
They're interesting problems. That's the thing. Like I'm an underground mining engineer. I was trained as an underground mining engineer, but I have a very good, strong software background. I learned
Sure.
early on in my career that the computer could do the calculations far more accurately and far quicker than I ever could. So that's why I got into programming. So anything that involves software, I have a keen fascination with trying to figure out how it works. But if I spent too much time, I'd never get anything done.
Troy, now we've talked a lot about understanding the property of the rock, understanding where the holes must be put and what shape and size they should be. But that's not the only thing that you guys are doing development on. There's an exciting movement afoot also when it comes to uh, blasting technology and explosives, isn't it?
Yeah. Yes. Yes. So the third part of that whole system, with the first being the design of a good blast, the second being executing the drills correctly, the third is the loading and the charging of holes, basically positioning the energy and setting the
Uh-huh.
energy off at the right time. So I'm involved in a startup company called Nexco, and we've developed a brand new way to manufacture ammonium nitrate. I can't go into a lot of details because we're still in the startup phase of the idea, but the interesting part, especially from my point of view, the engineering perspective, because there's a lot of really cool advantages of it. This is a waterproof ammonium nitrate based product that could potentially replace most other types of explosives used in mining.
Wow.
It's energy variable, and it's energy variable through not through a density change. So you don't change the density to change the amount of energy. And the interesting
Okay.
thing that I really like about this is couple that with measure well drilling technology. So you on a centimeter by centimeter basis, if you understand how hard or soft it was easy, how hard or easy it was to drill a particular hole, you can
Mm.
tailor the energy for that and adjust it
Right.
on a centimeter by centimeter basis. So all of a sudden that changes the way you do blast planning. Now that
Mm.
you may not need to stagger your holes as much. You may not you may be able to deal with cratering in the hole or physical defects. Spalling or whatnot, where what
Mm.
happens if you've got a charge column that's say 20 meters long and halfway down you've got a fault that all of a sudden went from a 100 millimeter hole to say 300 millimeters. How would you normally load that?
Yeah.
With this particular product, you can just lower the energy down to get the equivalent energy
Mm.
at that particular location without doing that. So it's very exciting. Like I'm still focused mostly myself on underground drilling and blast design, but this product could be used underground, surface, anywhere. It's very exciting product to use
So
for.
this company Nexco is one to watch, right?
Yes, it is. Yes, it is.
And it's
Um,
not the only new company that you're involved with. When
yeah,
we chatted recently in Toronto during PDAC, you were quite excited about One Red Maple, and that's
yes,
kind
one
of
red.
also connected sideways to mining, but certainly not to mining it exclusively.
Well, one of the owners of the Iron Company, Mark Sherry, he had an idea during the pandemic. Well, he's a serial entrepreneur. He's got a few companies under his belt that are going strong, but he had an idea about online shopping and how it was taking business away from local retailers. So he, he ended up coming up with the concept of one red maple. And what it is, it's basically an interception application. And what that means is that if you're searching on Amazon for a particular product, our browser extension will pop up and give you a list of exact matches to local retailers, and it'll tell you what the cost differences are, so that you have the opportunity to click on the button and it'll take you right to their site, and then you can purchase that product locally through their site, or you could go into the store, any number of options. Essentially, we've got it working now with all major sites, including Google. So if there's any product descriptions, it'll pop up and show you where everything is locally. It's a browser extension and a mobile app. It's really quite cool technology. I'm not so much involved on a operations side with this company. I'm sitting on the board and providing advice and software. But the interesting thing is that it's a cloud-based system, big data problem. It's a hugely big data problem that they're dealing with. And we're co-located in the same offices, so the same pool of developers that are working on iRing have access to the developers that are working on this product, which is really cool. There's sort of like a little Silicon Valley thing happening here, which is kind of nice. A lot of collaboration going on. So the developers that are working on iRing have very strong computer science and mathematics backgrounds, 3D, geometry, gaming, surprisingly enough, is pretty important to the type of work that we do, because it's all 3D visualization, and to be able to render something in 3D, you need that background. We've got mining engineers, and then on the One Red Maple side, a lot of DevOps, a lot of cloud developers, front end and back end stuff we don't have. So it's kind of nice to be able to know that if we run into a problem, we have access to other resources. And I think, honestly, I think we're going to run into that problem with our RockScan Pro, because it will generate thousands and thousands of data points. To give you an idea, in 3 seconds, measuring a dynamic event, it can capture 90,000 points per channel, and that's over 3 channels it has. So it's a tremendous amount of data, and that's just one probe. And we have to be able to analyze all that data. So I'm actually looking forward to solving that problem. But
So
once we get
speaking of
out there.
solving problems, of course, generating a lot of data underground sounds fantastic, but you've got to get it out from there in order for it to become useful, or you've got to handle it underground. And this is a very typical problem that most mines, specifically underground mines, of course, have. That that connectivity and bandwidth underground and reliability thereof is not fantastic. So how do you overcome this, or how do you see the industry overcoming this?
Well, honestly, I think it's a solved problem from probably 30 years ago. When you were on dial-up networks, you'd have to build the apps to assume that your network was shaky and fragile, and
Right.
you'd build it almost like a P2P style system. As soon as your device gets connectivity, it connects and exchanges data and goes from there. I know some of the mines in the Sudbury area are moving over to an LTE network underground. They'll probably have they'll probably end up having a better cellular network than most of Northern Ontario. But I
Not
think
to
they
speak of the
are.
roads, but anyway.
Yeah, exactly. And I think they're probably an anomaly. I think for the most part, like the way we're structuring our technology around the RockScan probe, the RockScan probe itself will host a web server. Essentially, it's going to have a little Wi-Fi router. So mines that don't have any connectivity, if you've got a mobile device, a tablet, or anything with Wi-Fi that's been certified for underground use, you can go up to the probe, connect to it, download the data, and then when you reach surface, our app will connect and automatically upload the data. And my philosophy is, for this sort of data collection, anybody that works for the mine should be able to collect the data in as easy and transparent as way as possible, right? The app should be sitting on their device monitoring for a connection, and if it recognizes the connection, it initiates a download and downloads the data, and then when they get to surface, it uploads the data. So it won't, in that case, it won't be real time. And honestly, I don't believe in real time. I think everything is near or very, very near real time, but never actually real time.
Sure. But it doesn't need to be either.
No, it doesn't. Usually they won't be able to go underground after a blast anyway, because they have to wait for the fumes to clear. So it'll be after. And if they've got a Wi-Fi network, or if they've got some other network that we can connect, or if they've got Wi-Fi hotspots, they can connect. So it doesn't seem to be the connectivity doesn't seem to be as much of an issue as it was 10 to 15 years ago. But I still think the reliability might be a problem, and that's where you'd need to build the robustness in the applications to handle that sort of lag.
Yeah. Troy, it's been really, really interesting. It's been a bit of a whirlwind as well. Now, I love when when smaller companies are successful like you are, and you've been around hiring, and Aegis has been around for many years now, I guess.
Yeah, yeah.
So all the best with all of the new innovations that you're working on, and everything new. I think it is probably through, I don't want to call it micro innovation, but let's say not Silicon Valley based innovation like this, that at least the industry, goes forward. And love to hear about all your success.
Well, I'll keep you I'll keep you in the loop, MP. I'd love to come on in another year and talk more about
Yeah,
the successes we're having. But thank you very much for having me on your program. I really appreciate it.
yeah, absolutely. But before you run off, we usually ask all of our guests just before you go, what's on your bedside table? What are you reading?
Ah, okay. Well, that's a good one. What have I been reading for the last almost 2 years? It's a group of novels called The Wheel of Time by an author named Robert Jordan. There's actually
Uh-huh.
14 books, and I started reading it in January of 2021, and I just started the 14th book this month. So I'm hoping to be done in September.
Whoa, whoa. Is it what? So what's the genre?
It's a fantasy tech novel, essentially, a dystopian type future. Well, I would call it dystopian. Most people would probably call it more fantasy style fiction. But it's a good essentially. There's these so-called characters they call channelers that basically can do telekinesis and sort of things. And one of the main characters broke the world essentially. They call him the Dragon Reborn, and he was fighting the so-called Shadow Spawn, or the devil, essentially, what it would call. And he broke the world, and part of that tainted the power for men. So men would get insane if they developed this gift at birth, they would go insane. So for 3,000 years, the women have had the power in this society, which makes it's an interesting twist on
Yep, on what we've got.
social structure anyway,
Yeah.
where the women actually have the power and people fear the women. It's really, really, really quite a novel. But it is an investment to read though. 14 books in. I'm looking forward to finishing.
Troy, thanks a lot for your time. Really appreciate that, and we're looking forward to speaking to you soon again.
All right, perfect. Thank you. Have a nice day.
And you as well.